Welcome to initial value problems. So again, the idea here is when we take an integral, we have multiple functions that we could come up with. So when we take an integral, we have multiple functions. Again, the format capital F of X plus C, right? But if we happen to know the Y value at just one point, if we know the function value at one point, then we can figure out a specific C. So if we know the function value at one point, then we can find a specific function. So we're going to take an example in context. We're going to use the acceleration, velocity, and displacement or position that we've worked with before. So in this problem, I'm going to just give myself a little more space so we're not just right on top of things. All right. So in this problem, we have that a falling object has an acceleration of -32 feet per second squared due to gravity. Suppose a ball is thrown downward from the top of a 100-foot building with at a velocity of -66 feet per second. Then I want to know, what is the velocity function if t is the number of seconds after release? So in real life, we should have one specific velocity function, right? This is a real true situation. It's not like the velocity is going to be multiple numbers at one point in time. So we're going to use the fact that velocity is an integral of acceleration, more or less, right? So I'm going to say is an integral of acceleration. So the acceleration is a constant function. So essentially what we have is our velocity with respect to t. We're looking at an integral of -32. It's just the constant function. And then we're going to actually work with dt instead of dx. So the derivative or the integral of a constant, that constant can come out front. So we're looking at the integral -32 times the integral of 1 times dt. And so we get -32 times t plus c. The integral of 1 times dt was just t. So we have v of t is equal to -32t plus c for some c instead of for all c. And then we're going to use the fact that the initial velocity, right, at release, so when t equals 0, we were told that that initial velocity is -66 feet per second. And so what we're working with then, I need to give myself more space. What we're looking at then is that we have, if we plug in t equals 0, we have v of 0 is equal to negative 32 times 0 plus c, and this should also be equal to negative 66. And so we get c equals negative 66, and therefore, plugging back in, v of t is negative 32t minus 66. And then we have what is the height or position or displacement function. So again, our displacement or position or height is an integral of velocity. And so our height function, we're going to go ahead and take the integral of v of t dt, which is just the integral of negative 32t minus 66 dt. We could go ahead and split this out. So this would be negative 32 times the integral of t dt minus 66 times the integral of 1 times dt. We have a power rule situation with our integral of t dt. So this is t to the first. So it should go, we go up by 1, so it becomes t squared, and then divide by that same power. And then this situation, integral of 1 times dt was, we were just going up to t. Right? So 1 goes to t essentially, and then we have our plus c's. So we wind up with negative 32 times t squared over 2. And then we have minus 66 times t and a plus c for some c. Or h of t is equal to negative 16t squared minus 66t plus c. And then we know that the initial height, right, when t equals 0, is 100 feet. Presumably the ball is just thrown right from the top of the building. So whether someone's laying down on the top of the building, they throw it downward right from that 100 feet. And so what we have then is h of 0 equals 100. And so we have h of 0 is negative 16 times 0 squared minus 66 times 0 plus c is equal to 100. And so we get c is equal to 100. And therefore, h of t is equal to negative 16t squared minus 66t plus 100. So for those of you who have taken some physics, this may look familiar. This negative 16t squared minus the initial velocity, or plus the initial velocity times t plus the initial height is a very standard formula. And this is where it comes from. It comes from integration. So just knowing, so just a quick comment, note. So knowing just the acceleration, the velocity at one point in time, and height at one point in time, we can find the actual height equation. I'm actually going to change this from height to position or displacement. So, and position at one point in time, we can find the position function. And so we can figure out, say, in terms of height, when a ball hits the ground. There's a variety of things we can figure out. Just knowing acceleration, the velocity at one sole point in time, and the position at one sole point in time. And those points don't have to be the same. We could certainly use something other than t equals 0. You could always still solve for the c with whatever your t was.